As per the question, from the top of a tower, a stone is projected vertically upward. The point C is the top of the tower. Stone is projected vertically upward. It will go and reach a maximum height A. So A is the point of maximum height where the velocity becomes 0. Then it starts falling down from A. It will reach C, same height again. It will go down and finally reach the ground. When the stone reaches distance h below the tower, so after reaching the highest point, it starts falling down. Velocity will increase in the downward direction. It will reach back C, then it will go further down. When the stone reaches a distance h below the tower, so C to D can be taken as h. D or CD is h, so it is reaching h below the height of the tower. Its velocity is double of what was at a height h above the tower. So B, C to B also can be taken as h. As the object go upward, the speed will decrease. So when it reach B, there is a velocity. That velocity B, that decreases further and becomes 0 at A. Now as it falls down, the speed will increase. What was the velocity at B when it was going up? The same magnitude of velocity will come back when it reaches back B, but in the downward direction. Then velocity will again increase. What they are telling? The velocity at D, which is h below the tower, is double of velocity at B. That point B is h height above the tower. So as it falls down, the velocity will increase. At B there is a particular velocity. When it reaches D, that becomes double of that. That means the velocity at D can be taken as 2 times of velocity at B in magnitude. If it is downward, both are negative. Upward, you can take as positive. So the C to B distance is h. Even C to D distance also h. So if we count from B to D, B till C, then D total, B to H, distance wise. We'll take negative or positive with respect to, we'll take the direction downward as negative, upward as positive. So I think the question is clear. Starting from the top of the tower is projected upward. It reach B, that's a height h. Again go up, velocity becomes 0. As it fall down A, or fall down from A, the velocity will increase. There is a particular velocity at B, which is height h above the tower. That will further increase in magnitude. Then when it reach h height below the tower, the D point, the velocity at D is twice the velocity at B. That means the distance from C to B and C to D both are h, total 2h. And the velocity at D is 2 times the velocity at B. Now show that maximum height attained by the stone. Maximum height attained by the stone is S of CA. S from C to A is equal to 5h by 3. This is what you have to show that. So C to B, we already have C to B is h. So if you can find B to A, then you can add SCAS, SCB plus SB. So you want the displacement from B to A. So if you count B, A, we have final velocity as 0, but we don't know the initial velocity at b. So before applying AB with final velocity 0 and other factors, you need to find velocity of b. The only connection given in the question is velocity at b and velocity at d. That means velocity at d is given as 2 times the velocity at b. So using BD, downward movement of BD, we find velocity of B first, then we can go back to BA. Otherwise, we cannot apply BA because initial velocity is not clear. BD. BD in the downward direction. So acceleration due to gravity is minus g. The displacement of B to D. B to C is h, C to D is h, 2h. Since it's downward, minus 2h. So displacement, acceleration, then the u is the velocity at B, that is negative. V, the final point D, that is the velocity at D. It's given, that is 2 times of velocity at B. So u is minus Vb, Vd is 2 times of the velocity at B. Now this connecting very clear, v square equal to u square plus 2as. V square equal to u square plus 2as. V point is D, Vd square equal to u is b, Vb square plus 2a into s. Vd is 2Vb, whether it's negative or positive doesn't matter, it's going to be square. So it will be 4 Vb square. Vd is 2Vb, so Vd square will be 4 Vb square equal to Vb square plus 2 minus g. Displacement is s between B and D, that is minus 2h downward. Now this will go left side. 4Vb square minus Vb square is 3Vb square equal to 2 into 2, 4 minus minus plus 4gh. From that you can find Vb square as 4gh by 3. Now after getting Vb, now you can go back to AB or BA. We'll take upward motion BA, B2. So the final velocity, which is velocity at A, that is 0. The initial velocity, which is velocity at B, that we have 4gh by 3 already here, root of that. So we square it, u square, v square, then you can directly take 4gh by 3. Now the displacement between B and A is what you find. So acceleration is always gravity is minus. So again using v square equal to u square plus 2as, 0, u square is same as 4 gh by 3 plus 2 into acceleration is minus g. Displacement we don't know here, we are finding s. So this will go other side, minus, so 2 g s dA equal to 4 gh by 3. 2 will go, gg will go, s b2a equal to 2 h by 3. Our aim is to find SC2A. So SC2A is already discussed here, SCB plus SBA. So SCA, the total height, maximum height will be SCB. SCB already given as h plus SBA, that we calculate as 2h by 3. So if we add this 3 by 3 common, 5h by 3. This is a problem maybe in understanding the question, because they given an arbitrary point B and D such that the velocity at D becomes 2 times velocity at B. the B is not the highest point. It's one point in between the highest point and the starting point, and D is not the ground. D is another point between the ground and the height of the tower. So as it falls down, the velocity increases. What they're telling, when it reaches a height h below the tower, that particular point, the velocity is 2 times the velocity when it was at a height h above the tower. So that particular point may be confusing. And after that, we need to find SCA. So SCB already we have H. Then we have to find SBA. So when we try to apply for BA, we don't know the initial velocity of the stone at B. So that can be found only from this particular relation, because they told you these relations. Velocity at D is 2 times of velocity at B, and the height is the displacement. The total distance is h plus h2h. So that's why we came back first time to B. Acceleration is minus g. Between B to C is h, B to D, total 2h, downward minus 2h. Then is substituting b square equal to u square plus 2h. Find VB. With that VB value, then we are going to BA. After finding SBA, we are adding SBA plus that to get the total height.